Good morning to one and all. This is Benerjee here going to present the term project on data analysis for the comprehensive task tracking and the management in the construction project. And this is my term project. Coming to the outline of this presentation, first I'm going to tell about the introduction and followed by the literature review and followed by data description and the data analysis methodology and the detailed analysis of task tracking and management in the construction project. And at the last, I'll discuss about the results and the conclusion. Coming to the problem statement, mainly the construction industry faces a lot of challenges in managing the project tasks due to underutilization of extensive data. Like we have the lot of data, but we are unable to use the data in the proper manner, and the ineffective data management results in the delay in the duration, which ultimately lead to the increase in the cost, and it also lead to the difficulties in maintaining the safety and the quality standards. Moreover, this project aims to the leverage the data analysis techniques. Like we use the data analysis techniques like by using Python for the better task tracking and the identification of bottlenecks, like the what are the key issues and how can we minimize those hurdles, and such that we can reduce the cost and time, and deliver the output in the more efficient way. Coming to the objective, the improve the to improve the overall project efficiency through structured data insights and informed decision making. Like we have the data and we will visualize in a proper way, such that we can give it to the client the exactly what to do and how to use this data, like how can we reduce the cost and the duration of the project. Coming to the first, I have done the literature review about the overview of construction project management. The first, coordination and the monitoring and the management of various activities and the data, and the is most key for the essential project success. Like the firstly, there are various challenges for the data utilization. Like extensive data is collected, but we couldn't use it in a proper way, and which ultimately led to affect the decision making and optimizing opportunities. Coming to the adoption of data analytics in the construction industry is at present it is one of the key factor in reducing the cost and the time, if we use it in the proper way. Like for the adoption of data analysis, there is a growing interest in the leveraging the data analytics for the efficiency. Like addresses like there are various challenges over the time, like time, cost, resource management. There are the limitation for the data driven models, like complex and the vast nature of construction data, and there are ongoing challenges in the effective information management. Coming to the literature review, I have done a literature review on the challenges in the construction project management. The construction projects generates extensive data throughout their stages, but often they are underutilized and affects the decision making and optimizing opportunities. Data driven models through promising the face limitations due to the vast intricate nature of the construction data. Coming to the emerging role of data analytics, there's an increase in the improving the time. The studies, the highlights the application of there are in this literature review I came to know there's application of data mining, the machine learning, emerging technologies in enhancing the construction project management. Coming to the data description, I have got this data from an open source, which I have placed in the references of the report, which you can access. And coming to the data description, I have the construction data PM forms and the construction data PM task, which is in the Excel format. Coming to the methodology of this project, what I've done is first the data loading and exploration. Like first, I have the collected this data from an open source, like of an site of a project, and later on, the after data loading and exploration, I have went to the data cleaning, like if there is any missing values and if there is an unnecessary columns, I have dropped those sections. And the next I have went to the data transformation, where I use the time-based calculation, the future engineering, and by using the this all by using the Python and the stuff. Coming to the statistical summary and results, I have summarized the statistics and the by using the bar graphs and the pie charts. Coming to the visualization techniques, I have used Matplot and the Seaborn libraries. Coming to the data analysis, I have used the completion of time analysis, form analysis, overdue task analysis, and the temporal trends. Like the first coming from the project, we have done the analysis of mean completion time for the task categorized by the type and the longer duration. The design team, the average is 111 days, and the shortest duration, the subcontractor inspections complete in just over 10 days. The other task durations, the other structural tasks are 54 days. The MEP services are 28 days. The site management safety inspections of 19 to 22 days. And as you can see, the x-axis and the y-axis and the time to close, for the each one, like for the project management, it took 20 days, and sorry, for the 0 days, and the head office 20 days, and the design team, it took more than 100 days, and the inspection, it took 20 days, and the permits and the quality one structural, it took around 50 plus, and the quality two, it's 20 architectural, 20 days, and the civil, like over the time, it tells us by using the data, we have found that the time for the each task to be completed in by using the this bar graph. Coming to the analysis of form completion status, the 73.5% of forms are closed, majority of tasks are completed, and still 26.5% of forms are still open, like which indicates there are pending tasks. And the potential open task may highlight the slowdown of the project and unresolved issues in the project process. Coming to the temporal analysis from creation of the patterns, as you can see, there is a growth from 2019 till almost mid of March. There is a steady increase in the in the form creation, and it peaked during the July 2020, and it gradually got declined due to a reduction, possibly due to the project phase shifts, or there is a reduced activity. And the average time to close by form type, there are various closure times, like for example, structural framing system took around 50 days, and this all indicates the various tasks in the projects, and the various closure times significantly differences in times to close forms, with some taking much longer, and there is an investigation needed. Forms with over 300 days to close highlight the potential issues, like procedure hurdles or resource shortages, and the process improvement. Identifying these delays helps the target areas for enhancing the task completion efficiency. Coming to the distribution of tasks across various task groups, this is a blue column indicates the safety. The 71.8% of tasks prioritize safety, highlighting its critical importance. The safety is the very important criteria in the construction sites. Coming to the administrative coordination, like administrative coordinates, like it stands around the 11.5%, indicates the essential coordination activities are ongoing. And the design influence, the design team accounts for 9.2% of tasks, underscore which is underscoring the importance of planning and architecture in the workflow. And coming to the quality, which is also the very important task, like the quality related activities represent 7.52%, reflecting the commitment to maintain the highest standards in the construction deliverables. uh, Coming to the overview of task distribution among the projects, the high workload projects are projects 1328 and 1330 dominate with a 30.2% and 29 0.7%, which is the half of it of the task load respectively. Coming to the moderate contributions, the projects 1338 task number. This number indicates the number of tasks per projects, and 1338 and 1335, which is almost 20%, and 1348 points, which are the moderate contributors. And coming to the lower workload projects, the projects with 1345, 1329, 1343, which stands with a 4.51, 3.85, and 3.07 percentage. And the workload imbalance, the concentration of tasks in the few projects suggests that there's a need for the better workload balancing. Like there is need to be a more balancing in the workload. Coming to the average closure times, the key points are the design tasks. It took the longest average completion at the 40 days due to inherent complexities, and the quality task average of 25 days, reflecting the thorough review process. And the safety task, it would quite quick, at about 10 days, necessitating that immediate action. And the site management, an average of 15 days, focusing on organization and the workload management. And coming to the complexity influence, the completion times vary by task complexity and the priority, highlighting the improvement areas. Coming to the distribution of tasks across top grade packages, the main contractor has the main number of tasks equal to almost 3461. The design package contains of 1042 tasks, which shows the important place of design activities in the project. The other significant trade bundles is the construction management with 781 activities, and the concrete formwork of 765 activities. Most of the works with a moderate task loads comprises of internal partitions, ceilings, groundworks, and related to the structural and the foundational features of the project. And the other packages like formwork, concrete, scaffolding, and handling between 300 and 400 tasks. And as you can see, the groundworks and the scaffolding of which took how many number of tasks, like the main contractor, it indicates the number of tasks and the trade packages. Coming to the analysis of average task completion time across project and departments, this the blue line indicates the exhibits the highest standard deviation. Just again. Highest standard deviation with task completion of ranging from 30 to 80 days. 30 to 80 days, indicating the variability and the potential complexity in design related tasks. And this red line indicates that the decreasing trend dropping from 30 days to nearly zero for the later projects, suggesting the improvement of efficiency or a shift. Coming to the site management, it is indicated in the green line, displays that the constant task time completions between 10 to 30 days, reflecting a stable operational status. Coming to this purple line, most tasks completed within the 0 to 10 days indicates that the safety concerns are generally addressed and very promptly, and the potential due to the straightforward nature of these tasks. Into the distribution of task causes, housekeeping, it is one of the top of the safety, the 4500 reports. And the safety, it ranks seconds with nearly 1500. The focus on accessibility and emphasizing the importance and the safety measures. And other issues, exclusion zones, workmanship. And the less frequent causes issues related to management, environmental, and documentation, and have a few report tasks suggesting that they are either less problematic or more effectively managed within the safety framework. Into the conclusion, the data-driven solutions enhance the monitoring, task monitoring, and the control in the construction project, and the efficiency in optimization. Structured data aids us in tracking the complex time and the workload management, and we need to focus on the areas like safety, design, quality, and which are critical, and the room for the which is a need of an hour in the designing and the safety tasks. And coming to the visualization techniques, Utilize the data visualization and the statistical analysis for the more performance enhancement, like better task tracking. And coming to the integration, we need to emphasize the importance of data integrations for the timely decision making in the project management. And these are the references we have took for the project. Thank you very much for the Professor Lugao for giving me this opportunity to present on data analytics for the comprehensive task tracking and the management in the construction project. Thank you very much.